Okay, in this video we're going to be talking about the quotient of square roots. Quotient of square roots. Okay, first thing we're going to discuss is simplifying a quotient. And just like when we have to simplify a fraction, right, we try to see if we can find any common factors in the numerator and denominator. We're going to be simplifying a quotient. Let's say I have an example where I have the square root of 13 divided by the square root of 52. So I have two radicals, one in the numerator, one in the denominator. And what I can do is I can actually put them together all under 1, and it becomes the square root of 13 52. So you ask, well, what is that going to do for me, right? Well, let's take a look at our fraction. We work out 13 over 52. Is this actually in reduced form? And it turns out that it's not, because 13 divided by 13 gives me 1. And 13 is also a factor of 52. If I multiply 13 by 4, I get 52. So if I reduce the fraction 13 52, I actually get the fraction 1/4. So this is really the same as the square root of 1/4. And remember, 4 is one of those nice numbers. 1 is another one of those nice numbers that we call perfect squares. Right? Because 2 times 2 is 4. 1 times 1 is 1. So this is really the square root of 1/2 times 1/2. And since that's a perfect square, I get 1/2 out. Let's do one more. So if I say simplify the square root of 60 divided by the square root of 15. Again, in this case, it's easier to put them both under the same square root or the same radical. And if you notice, 15 goes into 60 evenly. So 60 divided by 15 actually equals 4. Okay? So I get the square root of 4. And again, that's one of those nice square root numbers. And the answer is simply 2. Another concept about quotients of square roots is something called rationalizing the denominator. Rationalizing the denominator. And if you remember, when we talked about rational and irrational numbers, a lot of our irrational numbers were the square roots of numbers that weren't perfect squares, right? So we want to actually rationalize the denominator so there's no square root. So the concept is that we cannot leave a square root in the denominator. So how do we get rid of this? Well, here's a key fact. Remember, if I take anything like the square root of 3 times the square root of 3, I'm going to get what's inside the radical back out, right? The square root of 3 times the square root of 3 is really the square root of 9, and then I get 3. And the square root of a times the square root of a is also a. Right? The square root of 5y times the square root of 5y equals 5y. Well, this turns out to be a very useful operation when we're asked to rationalize certain quotients. So if I'm asked to rationalize 7 divided by the square root of 3. So remember, we cannot leave a square root in the denominator. So what do? Well, I use the fact that square root of 3 times the square root of 3 just gives me a number that's no longer in the square root. right? It gives me 3. But again, what I do to the denominator, I have to do to the numerator so that I don't change the value of the fraction. So I know that square root of 3 times the square root of 3 gives me 3. And up here, I simply have 7 times the square root of 3. It's okay to have a square root in the numerator, as long as we don't have one in the denominator, and this will be our final answer after the quotient has been rationalized. So if I ask you to rationalize 2 divided by the square root of 5, right, I'm going to take 2 over the square root of 5, and to rationalize it, I'm going to multiply top and bottom by the square root of 5, because once I take the square root of 5 times the square root of 5, I simply get 5 outside, and on top I have 2 times the square root of 5 still. So these two are the same, but this one's rationalized. Okay, so now if we have, if we're going to take the square root of a fraction, we need to rationalize the denominator. Now, if you remember in our earlier problems, it turned out that our fractions reduced and we got nice perfect squares inside our radical. But in some cases, or in most cases, that's not going to happen. So let's say I actually took a square root of a fraction like this, a square root of 5/3. So remember, we could break these up. This is like square root of 5 over square root of 3. Okay? And now I have a fraction with a square root in the denominator. Well, what do I need to do? I don't need to worry about the numerator. I simply need to make sure that the denominator no longer has a square root in it. So I multiply top and bottom here by the square root of 3. So this conveniently becomes 3 times square root of 3 times the square root of 3 gives me 3. And remember, from my product rule, I just get the square root of 5 times 3, which gives me the square root of 15 all over 3. Now notice, we cannot simplify any further. You might look and see 15 and 3 and you know that they have a common factor, but you can't because you have this radical sign. That 15 really isn't 15, it's the square root of 15. So at this point, it's as simplified as it gets. Let's try another one. If I say rationalize and simplify the square root of 10/14. Okay, now this looks like a problem that we worked on a little bit earlier because the fraction inside can still be reduced, right? You notice that 10 and 14 are both divisible by 2. So that's the same as 2 divided by 2. So that's the same as the square root of 5/7. Okay, so I still have a fraction left in my radical. So I'm going to go ahead and split this up. And I still now have a radical in the denominator. So what do? I multiply it by the square root of 7. So the square root of 7 times the square root of 7 simply gives me 7. And up top I have the square root of 5 times 7, which gives me the square root of 35 over 7. And that's my answer. And again, that cannot be simplified any further. Okay, so far we've been working with just numbers. And so now we're going to introduce some variables. So rationalizing a denominator. This is a quotient involving a monomial. Okay, so let's try this. Rationalize and simplify 8 divided by the square root of 3y. Okay, there's nothing really special going on here. This is just like another quotient with a square root in it. And if I look at my rules, right, I say I can't have anything that has a square root in the denominator. The 8 doesn't have a radical sign, so I can't put them all together. So the way to get rid of that radical sign in the denominator is simply to multiply it by the square root of 3y again. When I do that, I need to do the same thing to the top, right? Because square root of 3y over the square root of 3y is 1, and I don't change the value of the original fraction. So now, by doing that, I can take 3y out of the square root sign, and up on top I still have 8, which is not in the radical, so that stays on the outside, times the square root of 3y. And that's as simple as it gets. Remember, this 3y inside the radical is not the same as this one outside. The values are different, so you can't cancel any further. Let's try another one. Rationalize and simplify square root of 3x over square root of 5. So now I have both the radical in the numerator and in the denominator, but the only thing I need to worry about is the radical in the denominator, so I multiply it by the square root of 5, multiply the bottom by the square root of 5, so I get 5, because it can come out. Then I have the square root of 3x times the square root of 5. Now since everything is underneath the radical, it's like this, which is just going to give me the square root of 15x over 5.